So here we are, section 4.3. 4.3, 4.4, and 4.5 kind of make up really the bulk of this chapter. And this is, I mean, you do congruent triangles and maybe pre-algebra if you took it, but you don't really do it like this. So here's the first section about congruence, and this is something we're going to see for the rest of the year. This just keeps popping up over and over and over and over again. So first of all, we've talked about congruent angles. Now we're going to talk about corresponding parts of congruent polygons, and we're going to prove triangles are congruent using the definition of congruence. So, first of all, definition of congruent polygons. What does it mean for polygons to be congruent? Well, what it means is they're congruent if all their corresponding parts are congruent, meaning all their corresponding angles. A is congruent to angle H because those two are in the same spot in the triangle. B is congruent to J because those guys are both in the same part in the triangle. C is congruent to K because C and K are in the same spot. And then AB corresponds to HJ. BC corresponds to JK. AC corresponds to HK, and then they're all congruent in the corresponding parts there. And then the last part of this is what we call the congruent statement. And the congruent statement tells us not only, what two figures are congruent, but it also tells us what corresponds with what. Because notice, A is in the first spot, H is in the first spot. B is in the second spot, J is in the second spot, C is in the third spot, K is in the third spot. Those two triangles are congruent triangles, and A corresponds with H, B corresponds with J, C corresponds with K. So that's what that's telling us in this congruent statement. And again, valid statements versus non-valid statements. So BCA is valid because B lines with J, C lines with K, A lines with H. But ABCHKJ is not, because even though A and H line up, B and K don't, C and J don't. So that's an important thing. And if your congruent statement's in the wrong order, it doesn't work. It's not a congruent valid statement. So that's something that people make mistakes on in chapter 4 quite a bit is you'll identify the congruent figures, but you'll have the wrong letter orders in your statement. This is just the first example to talk about proving that two figures are congruent by using the definition and then writing a congruent statement. So it's pretty obvious. I picked the really obvious one. We'll do the more complicated ones together in class. But the first thing you have to do is you have to talk about all the pairs of sides that are congruent. So you have to start doing our congruent sides. So sides. So AB is a double one. So that's the first side. What's the double one here? WX. Now when you list the sides, it actually doesn't matter what order you use, just as long as you line them up properly. BC has the single mark. So XY is the other one that has a single mark. CD has a quadruple mark. YZ has a quadruple mark. So CD is congruent to YZ. And then AD has the triple mark. WZ has the triple mark. Okay. So there are a pair of sides. Now our angles, we just go by, again, the angle markings here in the drawing. So A has a single mark, W has a single mark. Okay. B has a double mark. X is a double mark. C is a triple mark. Y is a triple mark. D, and then D has a quadruple mark. Z has a quadruple mark. Now, for making your congruent statement, because that's the last part, then what you have to do is just I always go by the angles. Just pick an angle and go with that. So you've got, for instance, angle A goes to W. So I'll maybe do like A, and then I'll just go in an order, A to B to C to D, and then pick the one that corresponds with A. Well, that was angle W. What corresponded with B? That was X. What corresponded with C? That was Y. What corresponded with D? That was Z. And there we go. All the sides listed, all the angles listed, congruent statement. Now this part here is very, very important. We're going to use this quite a bit throughout the chapter. And it's the fact of this definition of congruent, but instead of saying definition of congruent like we did before, we kind of write it out a little bit differently. So we have the phrase if and only if that's in that part of the definition of congruent polygons means that both the conditional and converse are true. That means it's a biconditional statement. We talked about that in chapter 2 briefly. So if two polygons are congruent, then their corresponding parts are congruent. So what we say is this, and it's something you're going to see in a lot of proofs later on in the chapter. Corresponding parts of congruent triangles are congruent, or we'll call this CPCTC. That's the shorthand notation for it. Okay, so you'll see this corresponding parts of congruent triangles are congruent, or we call it CPCTC for short. And what it basically means is, hey, two triangles are congruent, every part in them is congruent as well. Okay. Now, next, solving a problem using this stuff. All right, so in the diagram, ITP is congruent to NGO. Find the values of X and Y. All right, so ITP is congruent to NGO. Find X and Y. Well, let's see what we have here. I corresponds with N, so I is 65. That means N has to be 65. T corresponds with G, so if T is 75, that means G has to be 75. And P corresponds with O, so if P is 40, that means that O is 40. Right there. I can solve for Y. Because Y is 6Y minus 14, O is 40, so 6Y minus 14 has to equal 40. So to solve for Y, I add 15 to both sides. 6Y is 54. No, 14, not 15. Mr. Moyer, you guys are probably doing, where'd you get 15 from? I don't know. Just wrote up a number that I don't know what I'm talking about. Divide by 6, divide by 6. Y is 9. Now to solve for X then, let's see what our sides are. Well, IT corresponds to NG. So if IT is 7.5, NG is 7.5. Oh, there we go. Got that. Now, I wasn't really paying attention, to be honest. I just solved for Y first because it was easier to go to the angles. But we really needed to solve for Y first anyway because we know that NG is X minus 2Y. Well, unless I know what Y is, I can't solve for X anyway. So it kind of worked out nicely that I knew that. So 7.5 equals X minus 2 times 9. 7.5 equals X minus 18. Add 18 to both sides. 25.5 equals X. Okay. So there we go. There's X and there's Y. All right. Okay. Now, next thing in the video are a couple of theorems. And hopefully this makes sense because and it's meant to make sense, is that when we have two pairs of angles in a triangle, like if I go back to this problem here to begin with, okay, I'll just go back to this drawing. The third angles theorem says if two angles of one triangle are congruent to two angles of a second, the third are automatically congruent. So let's say we know C and K are congruent, B and J are congruent, A and L are the two leftover ones, they'd have to also be congruent. So let's go back to this last example. Let's say for a moment, okay, I didn't know that both of those were 40. Say I didn't know the angles. But I'll know that I is congruent to N. I'll know that T is congruent to G. Well, here's the deal. This adds to 140, those two angles do together. That only leaves 40 degrees for that angle. These two guys add to be 140. So that only leaves 40 degrees for that angle as well. So hopefully it's kind of obvious that if you have two congruent angles, the third pair has to also be congruent because since they are only 180 degrees total, there's going to be the same amount left over for both of them. So it's the third angles theorem. And then 4.4, polygons and specifically triangles have the same congruent statements as segments and angles. Reflexive property exists for them, symmetric property exists for them, transitive property exists for them. So all that stuff works out. To be honest, we don't use any of these very often though, but I wanted to cover them because they do exist. And so for your homework, then, we have this drawing here, diagram, RSV and TVS are congruent. Solve for the values of X and Y. So that's it. If you have any questions at all, please come in. I'll be more than willing to go over all of it with you, and we can work on it together. Thanks.